it's great to see this is a pretty good turnout here tonight. We're going to have, this should be an exciting talk. Our Jacob here he's a LinkedIn employee engineer. He works on the search analytic team. He's been working on Hadoop for a long, long time. He's also a Hadoop committer, as well as the PMC member. That's Project Management Committee for Apache Hadoop. And he's also working on the relatively new Apache project called Giraffe. So here you go.
Thanks, Heen. Evening, everybody. Like Heen said, I'm Jacob. I'm here at LinkedIn. I'm going to be talking about Hadoop tonight. This is going to be a relatively shallow overview because we've got a lot to cover. It's difficult to know how much depth to go into on these kind of presentations at this point because Hadoop's gotten a lot of press. A lot of people are talking about it, but not necessarily everybody's had experience with it. So we're going to go over the entire ecosystem tonight in not a lot of detail. But if you have questions on anything, just call out as we go, and then at the end we can circle back to anything that I didn't cover in sufficient depth. So, my name is Jacob Hohman. I work at LinkedIn. Usually when I do these presentations, I ask who's heard of LinkedIn, but since you all made it here, does anybody here not have a LinkedIn account? Brave man. Can anybody help this man get an account while I'm talking? So LinkedIn, professional social networking, 130 million members, great place to work, we're hiring. Specifically, at LinkedIn, I'm a senior software engineer. Like Heen said, I work on a team called Search Network and Analytics. We do all of the big data here, as well as Hadoop. We also work on projects like Kafka and Voldemort, which are open sourced. I'm an Apache guy. I work a lot with Apache. Specifically, I'm a committer and PMC member, as Heen said, with Hadoop. Before LinkedIn, I was at Yahoo working on Hadoop exclusively for several years. Yahoo's where a lot of the Hadoop development was originally done. If you want, you can follow me on Twitter at BlueBoxTraveler. So, what is Hadoop? This is the question that Wired spent about 30 pages this month talking about. So it's big enough now that everybody cares. And the basic answer is it's a system for processing mind-bogglingly large amounts of data that 8 years ago just would have been completely out of reach of anybody except for one particular company, maybe two. But before we start talking about that, let's do a little history instead. So we go in the Wayback Machine when a plucky little startup called Google had an idea of basically downloading the entire internet and doing some math on it. At the time, they didn't have enough money to buy the computers that they actually needed to do this. So instead, they came up with a system of using relatively cheap computers, linking them together, downloading the whole internet onto that, then doing math on it. This is how they went about getting all the money in the world. Now, Google is a great company, but what they don't tend to do is they don't open source a lot of their software. So if you hear about it, you'll usually hear about it from a paper, which is what they did. They wrote a paper back in 2005, Jeff Dean and Sanjay Ghemawat did, describing what they had done in the system that they built called MapReduce. This is what Google used to actually download the internet and then do the math. At the same time that Google was working on this, there was a plucky little open source search engine called Nutch, which is part of the Apache project, that was trying to do very similar work, because they're also a search engine. They also needed to download a large swath of the internet and do some math on it. One of the main developers there is a guy named Doug Cutting, who's pretty famous at this point, and he read the Google paper. He took the detailed description that was there and started coming up with a prototype as part of Nutch. At the same time, another company, Yahoo, also needed to download the internet and do a lot of math on it. They heard about Doug, they heard about what he was doing, and they hired him to take that original prototype that he'd built on top of Nutch and make it into a production-ready system. Over the next 5 years or so, Yahoo took it from a cluster of about 50 nodes to when I left, there were about 32,000 Hadoop nodes running at Yahoo. Last I heard, it's about 40,000 now. Yahoo is the main contributor to Hadoop, and they've been doing most of the work on it for quite a long time. In fact, they recently spun off my old team into a separate company called Hortonworks, which we can talk a little bit more about. And at this point, Hadoop is pretty much everywhere. There's not a company in the Valley that's not using it, unless we're talking about Google, of course. I don't think they're using it quite yet. There's even a name on here which I wasn't expecting when I made this presentation a few weeks ago, which is Microsoft. Microsoft has recently entered into a deal with Hortonworks to port Hadoop onto Windows as well, which sounds to me like a special kind of hell, but the interesting thing is that if you're also doing a startup now, judging by the number of in-mails that I get from startups looking for Hadoop people, it's amazing what Hadoop has done in terms of opening up new startups that would not have been possible otherwise. So that's the history. Let's talk about how it actually works. Hadoop is composed of two different parts, MapReduce and HDFS. This is the computation and the storage. Remember, Google invented this system in order to first download the internet and then do a lot of math on it. So HDFS is on the bottom layer. Let's take a look at that first. HDFS is the Hadoop distributed file system. Anytime you hear somebody say Hadoop HDFS and you want to be pedantic, you can point that. It's already got the Hadoop in it. So it's a file system. That means you can do all the regular file system things to it. This is a Hadoop. This is working with Hadoop HDFS. You can make a directory called foo data. You can copy some data from your machine onto the HDFS. You can run an LS on it. You see that we've got a regular output of LS. There's file permissions. There's a 3, which we're going to talk about a little bit later. There's owners and groups, file sizes, file modification dates, and the whole path. You can copy, you can RM, you can move it to the trash. It's a file system. You can even cat it and see that it's a simple little file. So we've got a file system. How does that file system work? This is a big topic, and again, not a lot of detail, but we're going to do it in 9 slides. So say that you have a file. Hadoop does really well with really big files. We like petabytes and terabytes worth of files. For this example, we're going to take Gettysburg Address, which is very short, and we're going to pretend that it's about 300 megabytes long. So we have this file we'd like to put into HDFS. First thing that HDFS is going to do is it's going to split it up into blocks. The default block size on HDFS right now is about 128 megabytes, although some people run it at 256, 512, even a gigabyte. HDFS will split the file into those blocks. The last block will be however many megabytes are remaining. And each one of those blocks it's going to make 3 copies of. We call these replicas. That's the 3 that we saw when we ran an LS earlier. The 3 is configurable, and it's desirable to how safe you want this file to be. For clarity, we're going to now color the blocks, the replicas, so that we can see where they go, because we're going to take those replicas and we're going to move them onto the individual file machines that make up the cluster. They get spread around the cluster so that we try to distribute them as evenly as possible. And watching over all of this is the name node. The name node is the machine in the cluster that's paying attention to all the other machines. It doesn't actually store any data, no data goes through it. Instead, what it does is it keeps a giant map, and it says all the green blocks are on data node 1, data node 4, data node 7, all the blue on 3, 5, and 8, etc. The name node's job is to watch over all the data nodes, so that when the inevitable happens, and one of those data nodes goes away, the name node will see it, notice it, look to see who else has replicas of that block, and demand that one of those copies over the blocks that just went away to another machine. This is where the 3x replication comes from. We can lose 2 machines at once and still be able to quickly make a replica of the data. If we lose all 3 machines, we've got a problem. However, the probability of losing data node 1 and data node 2 and data node 3 at the same time is very low. It's happened, but very, very rarely. If you have data that needs to be even more protected, just use probability and move it up to data node to replication 4, 5, 6. Any questions on that?
Is it built on top of the basic file system, or is it a completely separate OS?
No, it's a Java app. We wrote a file system in Java.
What about
Sorry.
What about the name node itself? That's just one.
Yeah, the name node itself, good question. The question was, what about the name node? The name node is a single point of failure. And this is where HDFS gets beat up on the most. There's 2 things to be said about that. One, single point of failure that doesn't fail that often. If you have 4,000 data nodes and you only have 1 machine that you have to keep up and running, that's possible to do. You can buy redundant power supplies, you can buy high quality RAM if you just have to keep that 1 machine up. There's another part, which is we have something called a secondary name node, which is not a secondary name node. Very poor choice of names. But it basically keeps track of everything that's going on. And if you need to, if the name node does go down, you can turn the secondary name node into a name node, but it's not an automatic procedure. Oh, I'm sorry. That was part one. And the second part was that we're also working on that right now. That's one of the main thrusts in the Hadoop project right now, is to build a distributed name node. Sorry.
So you may not lose the data node, but the block may get corrupted. So the 3 copies all have different values.
Right. The question is, you might not lose a block, but it might get corrupted. So the data node is continuously running checksums and as a block verifier. And as soon as a block comes up, we keep the checksum and we keep all the data about it. As soon as a block gets marked as corrupt, it's basically the same procedure. We just pretend like it got deleted and have it get re-replicated. Yeah?
Very basic question. Hadoop is good for unstructured data, right? Not for structured.
So the question is, Hadoop's good for unstructured data, not structured. This is correct in that you have a lot of data previously that you might have thrown away, but now because you can just add more capacity by adding more of these cheap boxes, you don't actually have to do the processing it into structured data, so you can keep it around as unstructured and then do processing on it later on. Yeah?
Yeah, you said there were tens of thousands of nodes. Do they all fit in a single cluster?
So the largest cluster right now is about 4,000 nodes, individual one. And towards the end of the talk, I'm going to talk about scaling it past there and what's happened there.
Can the data nodes be in different geographic locations?
The question is, can the data nodes be in different geographic locations? Not generally. Clusters are usually in the same data center, simply because the name node is keeping a very close eye on the data nodes. And if you're not heart beating in all the time, you start to have problems. There's a couple of projects to do something like this. Facebook has a project called High Tide, where you'd kind of have a data node that looks like it's in both, and you could replicate both back and forth, but it's not part of the main package. Cool. So now all you have to do is do that with 4,000 data nodes and 22 petabytes worth of data, which is about the largest cluster that's publicly known. It's rumored that there's government agencies with 3 letters that have bigger ones. So that's half of Hadoop. So we've downloaded the whole internet. Now we want to run some math on it. That's where we turn to MapReduce. MapReduce is a way of taking the distributed out of distributed computing. Distributed computing is very difficult. People spend their whole lives on it. It's mainly difficult because you have to deal with distributed state. So let's take the distributed state out of it. The basic idea is that instead of treating your data as something that everybody's working with, you treat your data as keys and values. Everything that's going to come into you that you'll need to work with is a key and a value. This works really well. We can say that it's a byte offset inside of a file if we're dealing with a text file. If you have a user ID and you want to pull in their profiles, like say your social network, the key would be the user ID, the actual value would be the whole profile. Hadoop got started doing a lot of log analysis, so you have a timestamp, and the actual value is what happened at that particular time, or also for social networks. You have a user, and you have a list of all their friends. So everything in MapReduce is a key-value pair. That's the basic unit of currency for our computation. So once you have those keys and values, you have to write a mapper. Mappers are going to take keys and values and emit 0 or more keys and values. These are going to get fed into a reducer, which are going to take keys and values and emit 0 or more keys and values. This is confusing, so let's talk about an example. We're all used to Hello World. When you start a new programming language, the equivalent inside of Hadoop is word count. I've never really seen a better example, even though this one gets a bit hackneyed at times. But everybody starts with how to do word count. So what we're going to do is we're going to take each one of those keys and values. We'll start again with 407 years ago from Gettysburg Address. Does anybody not know what Gettysburg's address was? Cool. When you're dealing with text files, like I said, the best way to think of them as keys and values is a byte offset in the file and the line of text. So in our case, the key is going to be 0 because we're starting at the beginning of the file, and the value is going to be 407 years ago. One flaw with the word count example is that we're not actually going to use the key. We're only going to use the value. And what we're going to do with that is we're going to split that line of text into a bunch of tokens. So from 407 years ago, we end up with 4 score and 7 years ago. Each one of those is going to be a new key and value that we're going to emit. Because we're going to count them, each one will have the key be the word, 4, and the value be 1. Everybody with me so far? No. I'm sorry? Yeah, we're very simple. We're not going to pay any attention to if there's repeated words in our text or anything else. We don't care about that. Every word gets broken up, gets tokenized, gets emitted with 1 as its value.
If there was another 7 there, that would also be another entry, 7, 1.
Yeah, so the question is if there was a repeated 7, it would be emitted as a separate 7 and 1. Yeah, in our naive calculation, yep. You could optimize it, but it works well for this way. So where did it get the 4 score and 7 years ago? So this process is actually running on top of the data node that we talked about earlier. This runs in something called a task tracker. You've written tasks. This is your map task. It's running on the task tracker on the data node. It's running on the same data node that that particular replica we talked about was. This is one of Hadoop's big strengths, is that instead of moving the data to the calculation, we just move the calculation to the data. So wherever there's a particular block that you need to process, that's where we're actually going to try, at least, to run the calculation. Yeah?
Would it run on each data node? You explained before that the piece of data gets replicated 3 times. So this calculation, would it run on each of the nodes, the same calculation?
Right. The question is, would it run on each of the nodes that has replicas of the data? By default, no. It will only run on 1 at a time because hopefully we only want to run it once to get the answer. There's a mode where if a particular node is not running fast enough, we might start up a second instance of this to see if that particular node could get done faster. But that's more of an optimization. So whatever your replication is, we will run it 1 time. But say that the task tracker that's actually running dies in the middle of it, we will notice that again, and we will run the calculation on another data node that has that block. The person that's deciding on which node it'll be run on is another process called the job tracker, which is basically the analog to the name node, for MapReduce. And because this is distributed computing, we're doing this on a lot of machines at once. This is all being done in parallel. So after we've gone through and generated a bunch of words in 1, we end up with all those words in 1 in a big pile. Technically, what happens is they get put on the local machine, and then they're sorted and shuffled. What that means is that we want to get all of the times that we had the word A and all of those ones, we want to get them all in the same machine. And instead of having individual values, we're going to take the values before and join them into one big list. So in this case, A showed up 7 times. So that what will actually come out of the mappers and go into the reducers is the key, which is A, and a list of all of those ones. All of that shuffling is done for the entire project, for the entire output. And then reducers are called. Reducers run on the same task trackers after all the mappers are done, and they get one of those lines of A and then a list of ones as their input. Each reducer will process all of them and start adding them up. So here we get A and a math bug. When I was doing this, presentation, I didn't have a Hadoop cluster, and I figured I was smart enough to be able to add up some ones, and it turns out I'm not. So my Scala script is what I'm going to blame for this one. Instead, we get a count of all of the individual words.
A should have been 7, right?
A should have been 7, yeah. I think maybe I just copied and pasted wrong. I'm going to go with that for my inability to count.
Same also with the one.
Yeah. So one thing that you'll notice is that we never talked about.
This value is only on one data.
Which values?
The count for A.
Right. So the output, the final counts, are just stored back on HDFS. Or they're written out to HDFS so they get replicated 3 times, just like everything else. They come out as just one big text file, depending on what your calculation is. So we've done a big distributed addition, we've done a big distributed sort, we did a big distributed aggregation, and you'll notice that at no point did I talk about what happens when task failures, except when I got prompted for, about how we load the input, how we split it, how the tasks talk to each other, which you'll notice they don't at all. These are the things that make distributed computing very complicated, and the things that we've completely sidestepped by using MapReduce instead. This is the big value, is that, yeah, Gettysburg Address, it's a small thing, even if we're pretending that it's 300 megabytes, but this scales up from 300 megabytes to 3 terabytes to 3 petabytes, because at no point did we ever talk about the magnitude of the problem that we're trying to solve. Question?
How do you keep the shuffling from overwhelming the network?
The question is, how do you get the shuffling from overwhelming the network? Keep it from overwhelming the network? You don't always. The shuffle is a very network-intensive process, and we definitely see some slowdown in the cluster in general during big shuffles. The shuffle can do that. The shuffle's done over HTTP, and basically you have the probability that every one of those tasks is going to have to talk to every one of the reduced tasks. So the shuffle is a big concern. Normally there's not enough intermediate data that it is huge like that, but it can be a problem when we do see it. Other questions? Cool. So once you start thinking of MapReduce, your job is to make every problem that you come across fit into this key value paradigm, fit into MapReduce paradigm, and Hadoop is going to worry about getting your data there, running it when it needs to be run, retrying it when machines fail. Like I said, computation and storage. So MapReduce is great. Using this simple idea of taking a mapper, taking in some keys and values, emitting some intermediate ones, bringing in a reducer, playing with them some more, you can do a lot of things. You can filter, you can add, you can sort, you can group, you can do all kinds of stuff. So MapReduce is great, except for when it's not. And there's a lot of times when it's not. It starts to be really not so great after you've written about your 30th MapReduce job that does kind of the same thing. MapReduce can really be thought of as assembly language for this new distributed computing operating system that we're building. And so people will get tired of writing in MapReduce, just like they got tired in writing in assembly, and decide to come up with new languages on top of that. One of the most popular languages is a language called Pig. Has anybody heard of Pig? Cool. Pig was developed by Yahoo to save its programmers from having to write these tedious MapReduce jobs. I couldn't find a good picture of the pig that didn't just look bizarre. So that's the best picture of the pig. That still looks bizarre. When you write a pig job, this does the same thing. It's word count. You'll see that we load some data off of HDFS using text loader, and we call it line. For each one of those lines, we're going to go ahead and tokenize it. We're going to group each of those by what we got. And then we're going to come up with a count for it. The actual pig syntax takes a little while to grok, but once you do, you see that you don't actually have to think in MapReduce anymore. You can think in much more of a procedural way of doing things. Pig is extremely popular. We use it here at LinkedIn for a ton of our stuff. I believe a majority of our jobs are done in Pig. Data scientists basically program in Pig all day long. It's a great way of being able to take these huge amounts of data, not have to think in key value pairs. Questions on Pig? The other language that people started writing was Hive. Facebook decided that they wanted to also process large amounts of data and didn't want to use Pig initially. So what they did was they took the language that already existed, which was SQL. And they started on an open source project called Hive. You can do word count in SQL, but it's really ugly. So instead, this is what just a regular Hive query looks like. The important takeaway from this is that it looks exactly like SQL. It's not fully compliant SQL, but if you have engineers that you want to give access to your Hadoop data to and they do not want to learn Pig, which happens a lot, Hive is a great alternative. We've recently started doing that here at LinkedIn. We've opened up we've put Hive on our clusters and given it to people, particularly security folks like it quite a lot. They're going nuts with writing real queries that they don't have to plan out and write whole Pig jobs for. And again, because these are running on the running on top of the assembly of MapReduce jobs, when you write one of these queries, what will actually happen is Pig or Hive will compile it down to a series of MapReduce jobs. So one Pig line or one SQL query could actually become 10 or 20, usually not that many, but quite a lot of MapReduce jobs that will run one after another to give you your final output.
So does that mean, like, if you were programming in Hive and you have like some sort of a customer class or type definition, then somehow that's translated to some sort of a key value pair?
The question is, if you're programming in Hive and you have some type of customer or class definition, how does that show up in Hive?
Well, how does it, I'm assuming, how does that translate into the key value pair that you mentioned?
So the benefit of doing Hive or Pig is that you don't have to think in key value pairs anymore.
So
Yeah.
somebody in the background does that translation?
Yeah. So what they will do is they will take your statement and translate it into something that's dealing with key value pairs. And what Hive does behind the scenes is it has tables, just like a regular database table, right? And so it will take each one of those lines from your table, each row from your table, and translate that into a key value pair. Your value will be the individual columns from that row, and start working with them that way. Yeah. So yeah, pig and hive are the way that you get away from having to think about key and values. Other questions? So, an elephant, a pig, and some really weird elephant wasp thing walk into a bar and solve all your big data problems. This is true, actually, for quite a lot of places. You can get away with just using these. However, an interesting thing happened that when Hadoop got really big is that, like I said before, it opened up all kinds of opportunities, all kinds of ideas that people hadn't thought they could do before because they didn't have access to a system that could deal with this much data. So one of the really interesting things that's happened is that a ton of other projects have sprung up around Hadoop. I would say that Hadoop, Pig, and Hive are the three big ones. Everybody at this point should have a basic familiarity with them. However, within Apache, there are quite a few more to look at. The most famous of which is Apache HBase. Has anybody heard of this one? Cool. So one of the things that Hadoop is really good at is batch processing. One of the things that it's really poor at is real-time processing. However, Google wrote a paper, this is going to be a recurring theme, where they described a system called Bigtable, which they ran on top of Hadoop in order to get real-time access to data that was in Hadoop. Somebody went and read the paper, started building up this new project called HBase. It's very popular. We're not using it here. I think we're one of the few companies at this point that isn't. After a long time, Yahoo actually has gotten involved and is now using it as well. StumbleUpon actually is a huge HBase user. Last I heard, they were actually driving parts of their website live from it. And they're the main contributors at this point. It actually originally came out of PowerSet. Does anybody remember them? Yeah, PowerSet, Bing. They were a natural language search engine that got bought by Microsoft a while ago. And then their committers couldn't commit for a long time. Apache HBase is great when you have all that data that you've moved into Hadoop and you want to get real-time access to it instead of having to run MapReduce jobs. It takes a little while to get used to its schemas and its column families and all that, but once you do, this is how you do real-time access. Interestingly, there's a new project called Accumulo that has just recently been donated to Apache. This is HBase as it was several years ago, plus whatever the NSA needed. Several years ago, the NSA decided they needed HBase, but their programmers were not allowed to contribute back. So they forked HBase, started working on it, developing several new features that they wanted. Have maintained that and developed it over the last several years, and have just now donated it back. So it's a fork. It has a few new features. There's like cell-level security. There's something called iterators, which apparently look a lot like coprocessors. I'm not much of an HBase guy, so I can't say that much about it. But if you do need real-time access, there's now a evil twin version of HBase that you might want to take a look at. The HBase guys and the Accumulo guys are figuring out what they're going to do now that they're kind of clones of each other. See if they can maybe merge some of these features back in. So Accumulo is a new project to take a look at. One of the biggest things that you're going to do once you have access to Hadoop is realize how much data you can store. And while it doesn't have to be structured, it is nice to have a serialization format. And so one of the big projects now is a project called Avro, which was started by Doug Cutting, the guy that did Hadoop originally all that time ago. And it's a new data serialization format. So think protocol buffers, think thrift, think we need another one, then we've got Avro. Avro is great. You define your language using the, you define your data serialization using its IDL, and then you can go ahead and write your data. One of the nice things is that it actually keeps the schema with all your data. So wherever your data manages to go, it always has its schema at the beginning saying, this is how you read me. It's a big advantage because then you don't have to keep track of the schema separately. Avro is very popular, and in fact, we're using it, I think, nearly throughout all of our data here at LinkedIn. One of the first things that I did when I joined LinkedIn was to take all of the Avro data that we had and write a system so that we could access it through Hive. That's out on GitHub if you have a Hive system and you have a lot of Avro data and you'd like to process it like it was a table. So Avro is the new data serialization format. While it was originally designed to be the de facto data serialization format inside of Hadoop, due to several complications that hasn't happened and we're actually using protocol buffers, Avro has an RPC component to it, which is not as mature as the on-disk serialization format, but is also quite interesting. Questions about Avro?
So the schema you mentioned, is there a language you use for it, like XML or something? Just like your XML schema, what?
Right. So for the schemas for Avro, by default, they're written in JSON. Although there is also an Avro IDL that is not very mature, but you can also write it in that if you'd like. One of the most popular projects that come out of Hadoop is a project called Zookeeper, which, say it with me, Google wrote a paper for a distributed coordination system called Chubby. Zookeeper is based on that, but it's not a direct clone, unlike the other systems that we've seen. So Zookeeper is when you have a lot of distributed coordination that you need to work with, which again is the opposite of what Hadoop usually does. Zookeeper is very low level. You normally wouldn't be using Zookeeper directly yourself. Instead, you'll write systems that rely on it. For instance, Apache Kafka, which is a real-time streaming system that we've developed here at LinkedIn, recently donated to Kafka, does all of its coordination via Zookeeper. Apache Giraffe, which is a project that I'll talk a little bit about, distributed system, has to coordinate, uses Zookeeper. So Zookeeper is going to be the lowest level system that has come out of this Apache ecosystem so far. One of the most interesting new ones is a project called HCatalog. HCatalog is combining the metastore for Hive, keeping all of the data, all the information about your data, and merging that back in with what Pig does. Once HCatalog, which is very, very young, is up and running, you'll be able to have one central system where all your metadata tells you where all your tables are, all their schemas, everything else, and you access them via HCatalog for whichever system you're using. So if you want to get your system through your data through Hive, you'll say HCatalog, I want to read this data, and you'll process in Hive. If you want to get it through Pig, you'll say HCatalog, give me this data, and then I'll go and process it through Hive, or through Pig. Sorry. They're also starting to look at combining this with HBase as well. And I'm interested in seeing if we can combine it with a lot of other systems. There's no reason why we couldn't also be able to store metadata for things like Project Voldemort, which is a key value store that's developed here at LinkedIn, or Kafka or somewhere else. Once you get Hadoop, you get a lot of data, you get a lot of metadata about it, and this is where you're going to be able to store it. Oozie. Oozie is a is a scheduling system. Once you have Hadoop, you're going to have a lot of jobs that you want to run. These jobs are going to be dependent on each other. Some jobs you're going to want not to run until the other ones are done. Some jobs you're going to want to run only if this job does. That's what Oozie is for. It was developed out of Yahoo. Yahoo makes extensive use of it. It's a pretty heavy-duty system, but as soon as you have regularly scheduled jobs that you need to execute, you're going to want to start looking at a workflow scheduler like Oozie. One thing that I didn't include because it's not an Apache, and this is kind of an Apache-focused talk, LinkedIn actually has its own, more lightweight scheduler that we use here called Azkaban. So if you're looking at a workflow scheduler, take a look at Oozie. Also take a look at Azkaban if you need something that's a little bit more graphical and a little bit more lightweight. There's Project Flume. Flume is a log aggregation system. Flume is great for when you have all your servers and you want to start transferring your data over into Hadoop. Flume will run collectors on your different machines, take those logs, ship them to Hadoop, at which point you can then start processing them with Pig, Hive, coordinated with Oozie. Flume's a new project that just went into Apache recently that came out of a company called Cloudera. There's also Project Whir. Whir is, so has anybody here heard of EC2? Right. Yeah, Amazon, Rackspace, and one more have now started selling basically Hadoop clusters in the cloud, where you can spin up Hadoop clusters completely virtually, as many as you need. This is a really amazing opportunity because those startups that I was talking about that can't afford even the minimal machines that you might need to get started with a Hadoop cluster can basically get a Hadoop cluster up and running for pennies per hour for as long as they need and shut them back down. What Project Whir is trying to do is it's trying to automate all of that so that you just write some scripts that say, hey, I need 4,000 nodes in Amazon with this configuration, with this software on them, and go run. So if you're looking at expanding out your Hadoop cluster or starting with your Hadoop infrastructure, EC2 or Rackspace or the other cloud providers are a great way to start. And in terms of automating that, you'd want to go to Whir to make it as easy as possible. There's also Project Scoop. Scoop fills the need of taking all the information that you'd previously stored in expensive databases and transferring them into Hadoop. This is where you can get your structured data from the database into Hadoop and be able to process it further there. I also think it has the worst logo out of all of them.
Go the other direction.
Hmm?
Do a structured database.
Oh, the question is, can you go the other direction from Hadoop into a structured database? You certainly could by just saving them out as like comma-separated values and then importing them there. But as far as I haven't heard of a project that explicitly does that. Usually we can overwhelm those databases pretty quickly. So you would want to either make sure that you were exporting either a subset of your data or had a really big database that could store all of this. So you've got your data, you're running up in the cloud, you've got Hive, you've got Pig, you've got a lot of math that you want to do on it. How do you make sure that it's actually right? We have our own unit testing framework as well, MR-Unit, which allows you to take those MapReduce jobs that you've written, give them some input, verify their output. This is big enough now to actually be a separate project inside of Apache. Mahout is a really cool project. This is designed to do machine learning on top of MapReduce. So they have all kinds of clustering, all kinds of support vector machine algorithms that they do within MapReduce so that you can just load up and say, here's my data, I want to do some clustering on this. It will go and turn it into quite a large number of MapReduce jobs and immediately process it that way. Mahout is being run by some very, very smart guys. They've got people from the university, people from Twitter are working on it. I heard recently that we're starting to take a bigger look at it as well here. Mahout is the Hindi word for Indian driver. So if you have a lot of, or for elephant driver, for somebody that steers an elephant. So if you have a lot of data science that you'd like to do on your data, this is the project for you. BigTop. I've listed a bunch of projects here. They all have to work with each other. They all have to come up and not crash. BigTop is, I think, the most recent project to actually join Apache. And it's designed to integrate all of these systems into one thing that works at the same time, which is a very important feature. Crunch. This is why I didn't include more text. Is that readable? Crunch is a new project that's come out, and it's based on a paper by Google. Again, people got tired of writing MapReduce jobs. They didn't want to learn Pig, they didn't want to learn Hive or the equivalents thereof at Google. So what Google did was they started writing a library on top of Java that makes it look like you're still writing Java, but what you would normally do as a for loop will get translated into a MapReduce job. So this is the word count example for Crunch. We're going to read the text file, which is going to be on HDFS. We're going to do a parallel operation on it, which is that for each one of those lines, we're going to go ahead and emit. We're going to split it just like we did in the original one, and we're going to go ahead and emit it. We're going to say that we want to store it as a string, and then later we're going to aggregate it. So even though this looks like you're writing just standard Java and you've imported some odd library, when you actually go ahead and get down to pipeline.done, Crunch is going to go ahead, consolidate this all, come up with MapReduce jobs, and submit it to your Hadoop cluster. This is a brand new project, just maybe a month old. Looks very exciting though.
Is this open source?
Yeah, this is open source. This was developed at Cloudera. They've put it up on GitHub and are planning to incubate it into Apache as soon as they can. They are looking for contributors.
So it would be distributed as part of Apache sometime soon?
I haven't seen the question is, will it be part of Apache pretty soon? I haven't seen the incubator proposal go in, but that's their plan. If they're not doing it right now, that's going to be very, very soon. It's Apache licensed, though.
Because this looks very attractive to me. So if I want to use this, how do I do that right now? I can't, right?
No, if you want to use this, you can. It's on GitHub. You can go Crunch Cloudera probably. Josh Wills or Willis is the guy that wrote it. You can download it from GitHub and start playing with it right then. They had a blog post on actually getting started on this. So Cloudera and Crunch will be the fastest way to find this. Yeah, this is great for people that don't even want to learn Pig or Hive. Okay. And the final project is Giraffe. I started to go into a lot more detail on this and realized that I would basically never shut up. Giraffe is really cool. It's what I'm working on full time at the moment. Remember back where I said MapReduce is great, but the other way to say that is MapReduce really sucks, particularly on one type of problem, which is large-scale distributed graph computations. As a social network, we're very interested in large-scale graphs, right? Because everything that we do here can be thought of as a graph processing system. And while it is possible and a great interview question on how to do graph processing using MapReduce and key values, it's not very efficient. Every single time that you want to do a new iteration of some computation in MapReduce Hadoop, you have to write it out to HDFS. And then you have to load the data back from HDFS. And then you do a little bit of math. And then you write it back to HDFS. And each one of those is a separate MapReduce job. So a certain company wrote a paper, and it was Google, and we're doing this again. They wrote a system called Pregel. Does anybody know the 7 bridges problem? Correct. Yeah, the 7 bridges problem is a very important problem in graph theory. Can you actually get past cross this river that has 7 bridges on it and only do it one time? The name of that river is Pregel. The name of Google's system for processing large data systems is Pregel. We're calling it Giraffe or Giraffe. And in Giraffe, we're going to be able to load up huge distributed graphs, do math on them very quickly, and not have to send it back to disk for the individual computations, and then be able to spit those answers back out. If this is something that you're interested in, this is a very nascent project. It came out of Yahoo Research a few months ago. We are not yet up to Apache Jira 100 yet. So if you're interested and want to contribute, we would love to find new contributors. I'm working on it full time. We have issues that are designed to get people going very quickly. And that's true of pretty much everything that I've talked about. With the exception of Crunch, all of these are Apache projects or Apache incubator projects. Apache Software Foundation is entirely volunteer driven. The only people that we pay are the infrastructure guys, because you don't want volunteers to wake up at 2 a.m. to turn the servers back on. So if you've been using this software, or if you're interested in using this software, a great way to get more involved is to actually go ahead and contribute. I maintain a list of what we call newbie issues. These are issues that are designed to get new contributors up to speed. It can be very simple. It can be fixing a typo, fixing a Boolean expression that can be simpler, whatever you want. It's about downloading the source code, making a change to 1 or 2 lines, running the tests, creating a patch, uploading it, working with the community. Once you do that, once you've got the actual mechanics of working inside of Apache, the problem of solving more difficult problems is not so daunting. So if anybody's interested in contributing or getting involved in this way, I encourage you to check out the link, bit.ly ASF newbie issues, and see if there's anything that interests you there. These are across the entire Apache space. I also maintain one for Giraffe because, again, Giraffe's cool. So Hadoop by the numbers. Usually when I do this talk, I talk about running 40,000 nodes, we're running with this many petabytes and everything. But there's actually new numbers that are more interesting than that, which is 20, 21, 22, and 23. So Apache Hadoop came along, got started, got really popular. We had version 15, version 16, 17, 18, 19, 20, and then stopped for quite a while. Apache 20 came out 3.5 years ago, I think. About that time, it got to be very popular inside of Yahoo. HBase came along and needed some things. People basically didn't get around to coming up with a version 21 for quite a while. Version 21 was originally released, and nobody cared, because at Yahoo, which was the main contributor, they were very much dedicated to maintaining the version 20 that they had. Those versions of 20 have now been released and are part of the Apache process. If you hear about Hadoop, you'll hear people talking about 0.20.201, 203, 204. These are the 200 releases. These are the most hardened and tested releases of Hadoop. As of a few months ago, they're also official Apache releases rather than just being something up on GitHub. And like I said, for a long time, we didn't have any releases. There is an effort right now to get version .22 out the door. If we do, it'll be a very good snapshot of where Hadoop was about a year ago. It has some new features, definitely worth checking out. There is some effort to get this done, but we haven't been able to come up with a lot of volunteers. As of about last week, we do have a brand new state-of-the-art version of Hadoop, which is called Apache Hadoop 23. This has the latest and greatest features. This has work that we've done in terms of expanding out the cluster from beyond 4,000 nodes, something called federation, where instead of going beyond 4,000 nodes, you can take multiple clusters of 4,000 nodes and combine them into one mega cluster, which is a very important feature. Also has something called MapReduce Next Generation. Has anybody heard of that? Also known as Yarn, also known as MR279, also known as, there's one more that they came up with, which is designed for the fact that MapReduce needed rewritten from scratch. After about 3,000, 4,000 nodes, MapReduce starts to fall over. This is not a big problem unless you have 3,000 or 4,000 nodes, but the interesting thing about this is the solution was to rewrite MapReduce from scratch. And as part of that, what they did was they separated out the scheduling components. This is neat because now we have a new scheduler which will allow people to write frameworks that aren't MapReduce but still run on top of Hadoop. Right now there's an effort to get MPI moved over to this new scheduler. There's a JIRA to get Giraffe moved over to it. A lot of interest in this system. That's going to be the biggest piece of work to come out of 23. If you have a distributed system and you're not sure about how to get it running at scale, you might want to take a look at 23 and MapReduce 2. This gets a little bit more confusing though, because we're now starting to talk about the fact that we think we're ready to go ahead and be version 1.0, which we've wanted for quite a while. And so what may happen, it's being discussed today, votes are being called. We may go ahead and take Apache 20.205, 206 I think is the latest one, rename that 1, take 22, if that ever gets released, call that 2, and take 23 as version 3. So in a week or so, we can go from version 20 to 3.0. Any questions about that? If anybody's worked with either Cloudera's distribution of Hadoop or the recently announced Hortonworks Hadoop data platform, I think, they're both based on the .20 series. Cloudera is based on Apache 20 and Hortonworks based on the 20.200 series. It'll be nice to get some good stable releases out, and hopefully we'll be back to a regular release schedule. So that's what Hadoop is. What about Hadoop at LinkedIn? Hadoop is a very big component of what we do here at LinkedIn. I'm a committer. We also have 2 other committers on staff. We are rapidly growing our clusters. A few of the places that we use Hadoop extensively. The People You May Know panel. And this is one of our biggest uses. You log in up to this up on the right, it shows you people that you probably should connect with. This is all done as a series of dozens, if not more than 100 now, pig jobs, which go through and compute who should be the most, who you should probably know but haven't yet connected with. Also, has anybody used the in-maps feature? This is pretty cool. What it does is offline using Hadoop, we will take your social network, we will use data science and machine learning to do clustering on that to identify the different groups that you have in your social network. So for, I think this is animals, I'm not sure. We were able to identify his groups of people as being from LinkedIn, as being from Carnegie Mellon, Yahoo Analytics. First we do the clustering. We also do the prettying up and coming up, making it look nice inside of Hadoop. And then when you go and ask for it, we'll present this to you, and you can print it. You have to have at least 50 connections, though, so if you don't, here's the carrot to get you up to that number. But this is a very cool data mining problem that's all done here in Hadoop. Another feature that another product that we've recently released is skills. So what we will do is we will go through our entire member base. We will identify skills that we don't know about a priori. We will then figure out who's the most experienced and well-respected, I guess would be the word for that, in any particular skill. So we have iPhone development, we have ballet, I think is some of the ones we do. We have Hadoop here. So what the skills people have done, have gone through, found everybody that has Hadoop listed on their profile, not just by listing it directly, but also who you're connected with. There's lots of inputs, and has then ranked those people according to experience. Due to a bug, I am listed in there. I don't know how that happened. But you'll see, I've mentioned Doug a couple of times. There he is. Arun's over at Hortonworks. Tom's at Cloudera. Devraj is also at Hortonworks. So it's actually done a very good job of identifying these skills and figuring out who the people that are most involved in the community are. Again, this is all done here on top of Hadoop. So that's it. Any questions?
How do you test your code on
The question is, how do you test your code for ASF projects? It's up to each project. So some do it well, some do it poorly. Unit tests in general, but basically once you go into Apache, you get your own little corner of subversion, and as long as you follow the Apache rules, you're kept, you can keep pretty much to yourself, so it's up to each individual project. Hadoop has a huge series of what we call unit tests, which are really integration tests. Take several hours to run. There's no set framework that you have to use or anything like that.
So I'm just thinking, this can be layered on top of infrastructure as a service, OpenStack project to manage a large number of servers in the cloud. Just have metrics and
Right, the question is, can this be joined up with OpenStack and other cloud platforms? Probably, and in fact, there was a mailing list discussion, I think just a couple days ago, where somebody was talking about doing that. There is a lot of interest in this. So the OpenStack and the more general cloud people are very interested in this, but I haven't been following it.
so I work in that area and I'm learning about this. I can see current applications.
Yeah, no, it's definitely an area for more study. Any other questions?
So when you say the cheap hardware, what kind of hardware are you running in the cluster?
So the question is, when I say cheap hardware, what exactly does that mean? That means you go to your boss, you say, I've heard of this Hadoop thing, and I want to take 4 desktops that we just had sitting around, and you can build a Hadoop cluster off of that. That works. That will run. And you can do a great proof of concept, and that will be enough for most people, or for a lot of people. What that also means is that you can also take more dedicated, beefier machines with 40 gigs of RAM. You can join those together, and we'll scale up to that as well. So cheap hardware means accessible to your budget for whatever you need. So if you can afford cheap, we can run on cheap. If you can afford more expensive, you'll get more performance out of it, and we can run on that as well. It's basically commodity hardware. You'll want to load up on disk, because again, once you can't have the ability to store this data, you're going to find that there's a lot of more data that you'd like to store.
How does it scale with IOPS? Do you guys see the problem that this IO is doing this key value creation?
Yeah, so the question is, how does it scale with input-output operations? As we're going through the data, we're loading it up, we're doing some processing on it, and then we're going to spill it to disk. So it's pretty consistent. Generally, most MapReduce jobs are going to be I/O bound because we're trying to load all of this data in. MapReduce is generally not too computationally complex on each key value pair. So then we're going to be trying to write it back to disk, spill it back to disk. So yeah, we are I/O bound in quite a lot of MapReduce jobs. You can certainly write MapReduce jobs that aren't, but I would say that most of them are going to be I/O bound. People are looking at using SSD, but we tend to burn those out really quickly, since SSDs only have a certain number of operations that you can do over their lifetime. So yeah, I/O is where you're going to see a lot of problems.
So you described really well. I think it's really good for the big data, right? But to make it useful at the end, you always need a visualization, right? And you have done really cool, I saw with the skills, right? Is there any help, any framework that is used in the visualization of huge amount of data that was processed by Hadoop? For example, what did you use in your skills graph that creates this nice graph?
You mean in the in-maps graph?
Yeah.
So the question is, how do you visualize the data once you get it out of Hadoop? I know that there are a lot of BI tools that are being integrated with Hadoop, so that you can go ahead and use those on the output data. Specifically for the in-maps, has anybody heard of a software project called Gephi? It's designed for working with graphs, and it plots those out. And we actually hired the engineer that developed Gephi as an open source project, and we had him do that. So in terms of like open source visualization projects, I can't really think of any off the top of my head. I would look at more of the BI projects that are working at integrating into Hadoop. And if you want, I can look up a list of those because I don't know them off the top of my head, really.
I assume that most people use Java. What if you want to use other programming languages, like JVM-based, Clojure, Scala, whatever, or C++?
Right. So the question is, this is all Java. What if you want to use something else? There's two options. One, if it's a JVM-based language, that's fine. You can write this stuff inside of Clojure or Scala, no problem. It works really well on Clojure and Scala because map and reduce are functional concepts. So Scala and Hadoop, or Scala and Clojure, you just start writing them. We actually have some Clojure map reduce jobs lying around here from somebody that used to do Clojure here. JVM, there's no problem at all. For non-JVM based language, there's a mode called streaming, where basically we spit every key value out to another program that you tell us to. So basically it's pipes. We'll pipe that out. You can, and to whatever script, whatever program you want us to pipe out each value to, we'll take it back in. So you can use basically whatever you want as long as it can communicate over a Unix pipe. Yeah, and pipes and streaming are very popular. It's a great way of taking existing code and using it with Hadoop. Question?
Can you recommend any concise guides to how to administer the
Can I recommend any?
setting up a new cluster for first-time users?
Can I recommend any concise guides for starting up a new cluster? Yeah, so Cloudera is a consulting company that's done a great job at building a lot of very good educational materials. Hortonworks is the spin-off from Yahoo's group that right now is working on generating their own materials, so I would look at both of those. Yeah, I would say that right now Cloudera is probably going to have the best educational materials. When I started doing this like 4 years ago, there was like 2 guys that had written a blog post, and then I wrote some blog posts, and they're still around. Yeah. Yeah, so way back when Google started this, we've done that. They've since now come up with a whole new file system. I can't remember what they're calling it, GVFS version 2, but they've got a better name. They wrote a paper. We haven't actually gone and taken a lot of stuff that's in there and moved it back to Hadoop yet. We've got so many things that we're working on here. I'm not aware of anybody that's directly taking the GVFS2 and trying to build a new project on it.
So the hardware OS has to be the same.
So the question is, does the hardware OS have to be the same? No. This is Java. So if you can get it to run, if you can get them to run, they should work. Now, you'll of course find weird things where that may or may not actually be true. So it's certainly recommended. Now, by hardware, do you mean the actual?
I have Linux and Solaris, whatever. I just want to have a small cluster.
If you're running on Linux and Solaris, we'll communicate to each other, but that means you have to have, 2 different configurations. Administering the cluster becomes twice as hard. But and we also actually have a fair amount of JNI code now to speed up some of the slower spots. So you'd then have to deal with that if you wanted to use the JNI. So it's best to keep it on homogeneous hardware, but we're not actually technically required.
Does the scheduling of the tasks or jobs take into account the speed of the machine, bandwidth related to it, and the speed?
The question is, does the scheduling of the jobs take into account the heterogeneity of the machines? So the scheduling is pluggable. There are several different schedulers out there, FairShare. And as far as I know, because this isn't an area that I've worked in a lot, they don't. They will assume that all your machines are the same. However, what you can do is you can schedule how many concurrent mappers should run and how many concurrent reducers should run on any particular machine. So if you have beefier machines, you can say, I'm going to have 4 map slots or 8 map slots on this one, and the less powerful ones will only have 4 concurrent mappers going at once.
How do you characterize that?
How do I
Characterize that saying, okay, it has to run only 5, it has to run only
How do you characterize it? It's, I mean, on the machine, each machine has its individual config file, and you'll just say, this is how many concurrent mappers you should have.
config file is fine, but how do you say that if this is a 4 CPU core machine and it can run only 4 jobs?
Well, I mean, so you can say how many actual tasks you want it to be running at once.
How do you characterize that, saying, oh, I can only run 4 of this, on this machine I can run 10 of them.
Right.
So how do you figure out that?
Each machine will have its own configuration file, which will say how many it should bring up. So if you had a situation where you had heterogeneous machines like that, you would have to have a different config file on each one, saying you should only run 4 concurrent tasks and you should run 8 concurrent tasks. So it's just a setting that you would.
How do you benchmark that, first of all?
How do you benchmark it?
Yeah, first of all, you should
Well, you can.
This can handle only 4.
You wouldn't necessarily want to have more than the number of cores you have, taking into remembering that the CPU should get a core and maybe you should have an extra core just for other tasks as well. So you wouldn't want to overload a machine. You'd want to keep it close to the number of cores that you have, because these are not multi-threaded applications. You can generally assume one mapper, one thread of execution. No, the configuration, we have a lot of manual configuration. This would be one of them. Especially if you wanted to run on machines with different capabilities, you would have to make sure each machine had its appropriate config file.
Are there special problems when you go to Amazon or Rackspace that you're dealing remotely with an organization?
Right. Are there special problems dealing with Amazon or Rackspace? When I'm not dealing with them here at LinkedIn because we have our own hardware. When I was a student, it actually worked really well, but that was many years ago. There are quite a lot of companies that do run their entire business out of Amazon, and especially the Hadoop part. eHarmony, I don't know if they're still doing this, but a couple of years ago, would basically every night ship all their data to Amazon, do all the processing in Hadoop, and ship it all the way back down. Weathervane is a big Clojure user, big new startup that's doing weather analysis for insurance companies. I believe they do the same thing. Weatherbill, but they just changed their name.
Changed it to Climate Corporation.
Climate Corporation, right. So yeah, I'm sure that there are special problems in dealing with EC2 and all that, but I'm not familiar with them.
Can you talk a bit about the machine configuration that usually used in Hadoop cluster? What is the hard disk size, RAM?
So the question is, what's the usual machine configuration? There's not a usual one. Some places like to load up on a lot of cores, a lot of CPU. Some places will do a smaller amount. You'll, in general, want to have one core per mapper, leaving one for the operating system and maybe another one for miscellaneous threads that are running around. One thing that you're going to run into often is that your mappers are going to run out of memory. So you'll have to figure out how much memory you want to give them so that they're not colliding into each other. So that can be anywhere from 512 to a gig. Facebook is really happy with using a lot of RAM. So basically, it depends on your job. There's not a specific enough answer I can give.
If you use multi-core capability, can you reduce the cluster size physically?
If you use multi-core capability, can you reduce the cluster size? Yeah, if you have more cores, you can certainly run more processing on them. But then what will happen is, depending on whether or not all your data is on one disk or multiple disks, you're then going to be I/O bound much more quickly. I'm sorry? Scoop? Yeah. Yeah, so Scoop is designed for taking things out of Oracle and MySQL and then putting them into Hadoop. So yeah, it's for relational databases. What you'll do is you'll tell it what the schema of the data that you're about to load in. It will go and talk to it or talk to the database over JDBC, and then start loading it into Hadoop. The question is, for Hive, do you have to have the database separate? I'm sorry, I don't understand. Right. 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 So the way that Hive works is that all your data is still stored. The question is just more of an architectural one on Hive. All your database will still be in. All your data will still be in HDFS. They'll be in the files that you stored them in. Hive maintains a separate metadata store where it keeps track and says that, oh, this file belongs to this table and it has this schema. That information itself is not actually stored in HDFS. It's actually stored usually in MySQL. So it will have a metadata store of the database information that it stores in another database. And then when you go to run a query, it will query against the metadata store, figure out what files it needs to look to on HDFS, translate your query into a series of MapReduce jobs. Yeah?
Do you have to tell it about the network configuration, or is it useful?
Do you have to tell it about the network configuration? You should. You can specify the topology of your network, which is really nice because then when it's distributing out those replicas, it will try to make sure that you have two replicas on one rack, but you also have a replica on another rack because it's quite easy to lose a rack. Yeah.
Redundancies you have in your network.
Yeah, you can tell it the entire topology of your network, and then it will take that into account when doing both scheduling and replica placement.
How the simultaneous access of different data blocks in the same node?
How does simultaneous access to different data blocks happen? Well, files inside of HDFS are read-only. We can now append to them very recently, but you cannot go back and change bytes in the middle. So since that will be read-only access, that won't be a problem. Is that what you were asking about? Yeah. Okay. Question? Right. The question is, Twitter recently open sourced Storm, which it was written by an amazingly smart guy named Nathan Mars, and it calls itself the real-time Hadoop or something. I don't know anything about it except that if Nathan did it, it's going to be very cool. But I'm afraid I don't know anything more about it, really. I would take a look at it if you need more real-time capabilities. Nathan Mars has also done a very cool library called Cascalog, which is another language that you can use to work with Hadoop that's based on Datalog, and another language called Cascading. It's very cool. But I haven't worked with Storm yet. But it's something that should be very cool. I want to take a look at it. Yo.
Do you hook up with things like RabbitMQ or its brother?
The question is, do I hook up with things like RabbitMQ or its brethren? No, we don't need any type of messaging system. There's actually a Jira right now to put some kind of messaging system into HDFS so that people could subscribe to events if they wanted to track them, at which point we might have to have a messaging queue, but right now, no. One thing that we do here is Kafka, which is our real-time streaming system. It's not a queuing system, but it's similar in some ways. And what we will do is actually load data from Kafka into our HDFS cluster via a MapReduce job that runs on a regular basis. Question?
In terms of kind of the use case, kind of coming from a relational database background, is what I'm familiar with. So at LinkedIn, obviously you're doing a lot of processing in Hadoop, but in terms of like with your front end, does the data that go directly into that file store, and are you constantly serving data out of that file store as well, or how does that work?
Yeah, no, we don't. The question is, how do we serve data from LinkedIn in relationship with Hadoop? So you do something at LinkedIn on the website. What will happen is Kafka will generate an event for it. That will occasionally get loaded into HDFS, as I mentioned before. We'll do some processing of it, and then we have another project called Voldemort, which is a distributed key value store. And we will take data out of HDFS on a regular basis and load it into Voldemort. And then that is where it will be served live on the website. So Hadoop itself is a batch system. It doesn't have any SLAs. The data, yes, the data is stored in two places, and we will regenerate the data and then load it into Voldemort as we need it, as it gets updated. I'm sorry. Yeah.
The question on the same line, you just mentioned storms is real time Hadoop. Can you explain a bit more what it really means and how is this different projects, also as you mentioned before, how they help make Hadoop and the whole infrastructure more real-time capable?
So Hadoop is always going to be a batch processing system. So if you want to do anything that requires any type of low latency, you'll want to look either at HBase, which is trying to build a low latency solution on top of Hadoop, or something that starts from a completely clean slate like Storm. And like I said, I don't know anything about Storm. HBase spends a lot of time and effort to load the data out of HDFS and then keep it in RAM, and then try to serve it from there. So they spend a bunch of time making sure that they have fresh copies of the data if they've loaded into RAM so that they can give it to you quickly. Low latency is never going to be a priority, really, on top of Hadoop in order to be able to maximize throughput instead. We can do a lot of stuff with a lot of data, but we're not necessarily going to do it immediately. Question?
So when you look for new lead, what kind of qualification are you looking for?
I'm sorry, when I look for what?
For newbie to newbie
Oh.
contribute?
Oh, what are we looking for newbie contributors? Everything, and I do mean that. Right now I have an open issue in Giraffe for a logo. So if you are a good artist, you can contribute at Apache. everybody. Apache is all about the community. So that means the users can contribute to discussion lists. They can ask and answer questions. If you're a developer, that's great. That's the most of them. If you are a technical writer, that's great. Anything involving technology is inside of Apache, and we would like any volunteers that want to help out.
So for giraffe, we understand the giraffe part. So why giraffe, the animal? I mean, what does that have to do with it?
Why is giraffe called giraffe? Because we've turned this into a very bad running joke about naming everything after animals.
So just pick giraffe.
Yeah, it's graph, and you put an I in it, and you get a giraffe. Yeah.
I'm just thinking logo-wise. Just have it.
Yeah, it's probably going to have to be a cute giraffe. We have a cute elephant. Does anybody here know how we got the elephant? So Doug Cutting, the guy that did this, his son, I think, was like 4 years old at the time, had a stuffed elephant, a yellow stuffed elephant named Hadoop. The project Avro now, another of Doug's children is really interested in airplanes right now, and there's an airplane manufacturer named Avro in the 40s, so that's where we get that. Another one of Doug's projects, Lucine, I believe is his wife's middle name. So this is all really Doug's fault. Yeah. Great, thank you.
Okay, well, thank you, Jacob.